Alright, this video covers section 11.2. It's about linear functions. We're going to talk about graphing linear functions, how to come up with a linear function if we're given a graph or some data, and then also we're going to look at some applications of linear functions. The first thing though is how do we graph linear functions, and it's really the same as graphing linear equations, because we know that the f of x, this is just like y. So this equation is really y equals 3/5 x minus 2. We're used to being able to graph like things, or excuse me, we're used to be able to graph equations like this because we know two things about our line. What do we know? Remember, if an equation is in y equals mx plus b form, then we know that m is the what? M is the slope, and that the y-intercept has an x value always of 0, but the y value is going to be whatever that b is. So in this problem we know a couple of things. We know that m is equal to 3/5, and we know the y-intercept is the point 0 what? -2. And so you should recall that the slope is the point 0 -2, and then it has a slope of 3/5. That means we go up 3. We remember slope is equal to rise over run. So that means we rise 3 and we run 5 in this case. So if we go up 3 and over 5, that takes us to the point 5, 1. We started out at 0, -2. And 2 points is really all that you need to graph a linear equation, or in this case we have a linear function. We put a line through those points. There we have our linear function. Remember, you should always label points on your graph. Okay, so the next one is another linear function, and this is like what we're used to seeing, y equals 4, because y is the same as f of x. So think about this for a second. We know this is a special case. It's missing the mx part of our line, which means it has no slope. Does that make it a horizontal line or a vertical line? You should say it makes it a horizontal line. It has a y-intercept at the point 0, 4. And if we draw a horizontal line through that point, every line, or every point on that line has a y value of 4. So that's how we would graph that one. Now let's do the opposite. Let's take an equation, or let's take a graph, excuse me, and come up with the function. And really, whenever we want to try to come up with a function, a linear function or a linear equation, we need two things. We need the slope and we need a point. And really, in this case, the place to probably start is to just think about a couple of points that are on this graph. For example, that point right there, the point 2, 1 is on this graph. Also, none of these points actually occur at intersections, but right there, that's the intersection of the point x equals 3 and y equals 6. And between those 2 points, we can see a rise over run. We can see a slope of this line because it has a rise, it has a run. Looks like it has a rise of 5 and a run of 1. So the slope is going to be rise over run. Rise over run, that makes 5 over 1, or just 5. But then there's another way to do it. Let's say you just have 2 points. The other way is what I like to call the wise up slope formula. It's m equals y2 minus y1 over x2 minus x1. That should look familiar to you. And basically you just take the change in the y values over the change in the x values. So if we take the 2 points that we found off the graph, 2, 1, and 3, 6, and we think of this first point as having an x-coordinate x1 and a y-coordinate y1, and the second point, let's label these x2 and y2, then we can calculate our slope to be 6 minus 1, y2 minus y1, over 3 minus 2, which gives us 5 over 1, or 5. So to calculate the slope, when you're given 2 points, you can either use the wise up slope formula, or if you actually have the graph, you can just count the rise over run. How many units do you rise? How many units do you run? Alright, so now that we found the slope, there's really 2 different methods that we can use to find our linear function. The first method uses what's called point slope form. That's what we want to use if we have a point x1, y1, and a slope m. And this form looks like y minus y1 equals the slope times x minus x1. And we have the slope is 5, and we have a point. We have 2 points to pick from. If we choose the first point, the point 2, 1, that's going to turn this equation into y minus y1, but y1 is 1, equals the slope of 5 times x minus x1, and in this case x1 was 2. Then we have y minus 1, distributing, we get 5x minus 10. And finally, if we solve for y, we add 1 to both sides. This gives us y equals 5x minus 9. And the only other thing that we should probably do is remember that this is a function that we were asked to find. The direction said use the graph to determine a linear function. So instead of y, we should use what? We should use f of x to replace y. So the linear function is f of x equals 5x minus 9. Okay, so that's the first way. The second way is to use slope-intercept form. And you recall that looks like, I already wrote it above, but y equals mx plus b. And again, we're going to use our point and our slope. So in this case, the point, the y value is 1. Our slope again is 5, and we're going to multiply that by our x value, which is 2. And we don't have b yet. We're going to find b here in a second though, because now we get 1 equals 5 times 2 is 10. So we have 1 equals 10 plus b. If we subtract 10 from both sides, we get that b is equal to negative 9, which means our equation then is y equals mx 5x plus b, but b we just found to be 9, so we have 5x minus 9, which is the same thing we found the other way. So do I care which method you use? Nope. You can use either method. I don't know which method you learned in your Algebra 1 class, but whatever way you feel more comfortable with, you're going to want to do that on this next test and homework and stuff. Alright, so let's see how we can apply this to something in the real world. There's many different applications that have linear models, and one such example is this example of a bowling party or a birthday party for children at a bowling alley. It says a bowling alley hosts children's birthday parties, and in addition to charging a base fee for the party, the bowling alley charges a certain amount per child attending. And they give a couple of hypotheticals here. It says that if 20 children attend the party, the total charge is $220. And if you have a bigger party, if you have 28 children attending, the total charge is $292. It says find a linear function f of x equals mx plus b whose input is the number of children attending and whose output is the corresponding total charge for the party. Well, that's significant right there because that's telling us how to organize our data. We have data. We have really, in the first scenario here, we have our 20 children, charge is $220. That's an ordered pair. Remember, the input, the x, is the number of children attending. So first of all, we have that if 20 children attend, our output cost is $220. That's our first scenario. Our second scenario is that if we have 28 children in attendance, the cost is $292. That's right here. If 28 children attend, the cost is $292. Well, remember on the last page when we looked at the graph, all we needed to find our linear function was 2 points. We had 2 points and we did everything from 2 points. Well, this problem gave us our 2 points. So what was the first thing that we needed to do? What did we do on the last page? If you need to go back and look, you can. But remember what we did was we found the slope. Slope was equal to the change in the y values. That's 292 minus 220. Again, you might want to label these to keep everything straight. Call this x1, y1, and x2, y2. So if we subtract the y's, 292 minus 220, divided by the change in the x's, that's 28 minus 20. This gives us 292 minus 220 is 72 over 8. And of course 72 over 8 reduces to 9. So we now have the slope. And I'm going to go ahead and use method 2 here to find our equation. So using y equals mx plus b, we know that if we use our first point here, we have 220 is equal to a slope of 9 times a x of 20 plus b, or 220 equals 180 plus b. And if we subtract away 180, that gives us that b is equal to 40. Which means our function is y equals 40. Excuse me, the slope was not 40, the slope was 9. Y equals 9x plus 40. But they actually wanted a function, so we're going to call this f of x equals 9x plus 40. Now they said they wanted it in that form, but it might make more sense even if they didn't tell us to put it in that form. It might make more sense to write something like the cost in terms of the number of children, n, is equal to 9n plus 40. It doesn't always have to use f of x. We could use any variables we want. But that's how you would come up with a linear function from the data. And you're going to need to be able to do this on the homework and in the next test. All right. So this next application is a business application. It has to do with costs and revenue and profit. And let's go ahead and read through the little setup here. It says the profit a company makes depends not only on what they make per item, but also on the cost of producing each item. In other words, you can't just make stuff for free. You have fees. And so the cost function, capital C of X, is equal to the fixed cost. That's things that don't change, like rent, plus the variable cost, maybe electricity or other things associated with producing items. The more items you produce, probably the more cost you have. There's also revenue. That tells us how much money will be earned by selling each item. Revenue depends on how much you sell it for, the price, and how many items are sold. And then the profit is the difference between the revenue, the money that comes in, and the cost, the money that you spend. So that's why we say that profit is revenue minus cost. And so we have a basic example here. It says Celia has started making decorative glass blocks, and she spends $250 on tools, and each block costs her $7.50 to produce. She sells each block for $20. It says find a cost function and the revenue function and the profit function. And we should assume that X equals the number of glass blocks sold. Okay, so remember, cost, C of X, could have fixed costs plus variable costs that change. And so what's the fixed cost in this particular example? You should see that it's that $250. Celia has to pay the $250 no matter what. So that's a fixed cost. And then she also has to pay $7.50 to produce each block. So her costs are going to be $7.50 times the number of blocks that she makes, plus that fixed cost of $250. That's how she builds her costs. Now her revenue, that's the money she makes, capital R of X. Well, she's selling them for $20 per block. So what's that equation going to look like? It's $20 per block times X, the number of blocks sold. Which means her profit function, remember profit is revenue minus cost, that means we're going to have 20x minus our cost, minus the 750x, and then minus the $250 per month. And if we combine like terms, that gives us 1250x minus 250. So part B asks us, how many blocks will she have to sell to break even? Well, if you break even, what does that mean about revenue and cost? Well, it should mean that revenue is what compared to cost? Revenue and cost are equal. If you break even, that means you spend as much as you make, so they're equal. And if we look at our revenue, if we look at our profit function, if revenue and costs are equal, when we subtract them, what are we going to get? If that's the case, then profit will be 0. If we spend as much as we make, profit is 0. So that's probably the easiest way to answer this question, is to let the profit be 0. That means our profit function, that was 1250x minus 250, has got to be equal to 0, which we can solve something like this. If we add 250 to the other side, that gives us 1250x equals 250. And then of course if we divide by 1250, that gives us what? That gives us 20 items. So if she sells 20 items, her costs will be the same amount as her revenue. And that does it for section 11.2. Thanks for your time. We will see you in class.